Okay. Going live. Rude much? Rude. Rudy boo. Hello, hello, hello. So what are we going to do? We are going to check our... Okay. La na 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 na. Go live, go live. Hello. So, what is this crazy thing? This crazy thing is called an abacus. This abacus, I'm hoping you can hear me. Ooh. This crazy thing is called an abacus. Sorry. Just trying to... Come on. There we go. Okay. So, we're going to count on the abacus. This is 0. This is 0. That's what 0 is. And then we do 1. That is 1. Now, when we look, we have 2, and then 3, and then 4. Right? And we have 4. Anytime the beads are touching this horizontal bar, it is considered counted. So when we look, we have 4. This is the horizontal bar, this is the horizontal bar, and this is being counted. I'm trying to... Right. So, what are we doing? We're counting on the abacus. Hopefully you can hear me. Okay, so what we're going to do is we're going to count. We have 0, and then we have 1, so this is 1. So just like this, if I have this penny, right, this would be 1 penny. And then if I had 2, this would be 2 pennies. 3, and then I have 3 pennies. And then 4, and then it'd be just like 4 pennies. That's what it'd be, 4 pennies. So we look, this is 4, this is 4, this is 4. Okay, we're enough. Oh, thank you so much for the hearts. Thank you so much for the hearts. So what we're doing is we're learning how to read the abacus. That's all we're doing. So when we have it, we have this is 5. This will always be the value of 5. So I'm going to replace this 4, and I'm going to move it out, and I'm going to show you that when we say 5, it will always be the top beat, just like a nickel. Then, just like a nickel, it is worth 5. So when we look, oh, come on. Okay, so when we look, we have 5. Now when we see it, we could do 6. So that would be like adding an extra penny. So then we have 7. We have 7. It would be adding a penny, right? And notice this is the same. Where I'm trying to relate that these 2 pennies and this is the same. Hello, Caroline. Hello, welcome. I see that you're here. Let me know if you have any questions because you're the only one here in the room. Welcome, welcome, welcome. I am happy you're here. Okay, so please let me know if you have any questions. But the first thing we're going to do is we're going to understand how to read the abacus, right? Why are we learning how to read the abacus? We're learning to read the abacus because then we can do adding, subtracting, multiplication, and division. Hello, Splendor. Hello, Splendor. So this is what are we doing? We're at 8. We're at 8 right now. 5, 6, 7, 8. We have 5, 6, 7, 8. That's what 8 looks like. So when we look, hello, this is 9. So I'm going to add another penny, and this is 9. So some people get kind of confused with the amount of the amount of beads that are there. Okay, it's okay. Okay, but then what are we going to do after 10? Well, after 10 looks like this. This is 10. 1 and 0. So if I replace this, it would be 10, right? This is a dime. This dime is worth 10 cents. So now how do we know what they all use? Well, this is where we're going to start talking about our place values. There's our place values. We have our ones, our tens, our hundreds, our thousands, our 10,000. Does that make sense? So when we look, we could do 20. So that'd be 20. And then this would be 30, 40, and then 50. We have 60, 70, 80, 90. Thank you. Thank you. If you have any questions, let me know. But the first thing we're doing is we're understanding how to read the abacus. So if I said 90, this is what a 9 and a 0. That's what 90 is, right? So if I did this, this would be 99. And then if I did this, it'd be 999. If I did this, it'd be 9,999. Oh, good. Interesting? Good. So then if I did this, it would be 99,999. Well, what about these two? Well, these two are the decimals. If you notice, the decimal sits between the ones and the tens. So it would be point, 99 cents. 99. Make sense? Cool. Thank you so much for the hearts. Thank you so much for the hearts. So this is what we're doing, is we're just learning how to read the abacus. When we read the abacus, so if I did this, what number do you think that is? If I did that, what number do you think that is? He learned about this in schools. Really? That's fantastic. Did he teach you? Oh, yes, Char. It is 555. Yes, it is. 55,504.55. Thank you. It's been so long since I've used an abacus. Oh, that's fantastic, Foxy. That is fantastic. Do you know how to multiply and divide, Foxy? That is cool. So when we're learning, we're just learning how to read the abacus. For those of you that are not understanding what we're doing, we are going to just do a little review. And when we review, we're going to do this is 5. And then when we do 5, this is 6, right? That's 6 because we have 5 and we have 6. Anything that's touching this horizontal bar is being counted. And then when we look, we have 7, 5, 6, 7. What is 1? Ooh, that's a good one. Chaotic. This is 1. That's what 1 looks like. So if I did that, that would be 1. Why is that 1? Because it's 1 bead. All the lower beads has a value of 1. That's why I have a penny. This penny is worth 1 cent. So my brain is fried, apparently. Jaggered. So when we're going to read it, right, we have 0. And then we have 1. Why am I here? The reason why I'm here is because I have this dot indicator that's right here. If you see this, there's a little dot right here. Those are my ones indicator. So when I look, this is 1, and then we're at 2. After 2, this is 3, right? Oh, yeah, thank you, Jagger. Good. This is 3, this is 4. I was going to say, why is your brain fried if this is like counting? Funny. Hello. Okay. So if we do 5, what's 5? Well, 5 will always be the top bead. This is so entertaining. I'm going to learn a lot. I hope so. I hope to go into I know 1 to 4 now. Yes, you do. So this is 5. The top bead will always be 5 no matter what. 5. No matter what. 5. So when we look, we're going to have 5 and we have 6. So I'm going to add this and now we have 6. So let me move these. That's what 6 is, right? Some people like to look at the number 6. So that's what 6 is. So we have 6. We have 7. So we have 7, right? 5, 6, 7. We have 8. Nope, that's not 8. This is 8. That's 8. There we go. 5, 6, 7, 8. And then 9. 5, 6, 7, 8. And then 9. This is my favorite. Thank you, Char. Welcome, 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 everybody. Thank you for the follow. Okay, so what are we doing? Well, what's after this? This is, we have our ones. Oh, you can't see that. There we go. We have our ones, our tens, our hundreds, our thousands, and our 10,000s. Thank you, everybody, for the very warm and supportive comments. The 100, yes. So if we did 100, it would be like that. 100. That's what would the 100 be, right? Oh, let me do that. Yeah. Thank you for commenting. Thank you so much for the wonderful, beautiful comments. Because looking at the other comments, they're like saying that they don't, what's the point? But what we're doing is we're learning how to read the abacus. Once we learn how to read the abacus, we're going to go into adding, subtracting, multiplication, and division. 10,000. 10,000 is this. 10,000. So it'd be 10. Oh, sorry. It'll be 10, 0, 000. That's what 10,000 is. Yep. Does that make sense? I understand. What? Right? I never knew it went so high. No, 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 no. The main brick, it goes higher. Oh, it goes higher. Why? Because this is only 7 columns. So if we do 7 columns, what happens? Well, this is 13 columns. In the 13 columns, right? 13 columns. This has really been on. More than 90% of it. Why is the abacus odd numbered? I don't know why. I didn't think about it, but I don't know why. yeah, you're right, because there's 21 beads and then there's 23 columns and 27. I don't know why. I think maybe because it needs to be in the middle. I don't know why. That's a good question. So then what's going to happen? We have our ones. If I decide to use the ones over here. So if you notice, I have my dot indicator. I have my dot indicators, right? I could choose this one. I could choose this one. But in Pokemon, right, we could choose one. Oh, that's what I need to do. So I want to choose this one as my ones indicator. So what's going to happen is then I can do this. So I have if you look at it, I have my ones, my thousands, my millions, my billions, and my trillions, right? Charizard, please. Hey, Kryptonite, you're welcome back. Did you miss me? I'm going to, yes, okay, Charizard. Yes, we will do Charizard. So, we could do trillions, however, because it's a number-based system. Yes. However, if you wanted to track, I missed my. I am back. I am back. Thank you for waiting. If you want to track the national debt, you could use a 23 column abacus. It works exactly the same. It's just bigger numbers because size matters, right? So what's going to happen is, okay, you move on to the ones. Yeah. So what I'm trying to show is size doesn't matter. So when we look, this is made out of plastic, and this is 13 columns. This one is made out of bamboo, and it is made out of 23 columns. I'm sorry, it has 23 columns. So we can track the national debt if I chose to do here. Now, if you notice, it still has the dot indicator, so it works exactly the same. And if you look, I'm still going to count. If I use this one as my, if I choose this one, it'll be 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 9, and then we still have 10. This will be 10. When we look, it's still the same thing with this plastic one. So when we have the plastic one, it's the same thing. If I did this, it'll be the same. It'll be 1, 2, 3, 4, and then 5, 6, 7, 8, 9, and then 10. So the colors have nothing to do with it. This is just pretty. What about the connection? Thank you. I have to go. Okay, thank you, Chaos. I hope to see you in my next live. Thank you so much for, wow, thank you guys so much for dropping by. Does it go to billions? It does. That goes to billions. That does go to billions. Thank you for, okay, good. I think I got it. Okay, so we're going to continue on. Okay, we understand how to read the abacus, yeah? So let's go into, that's my net worth. I hope that's my net worth too. So what are we doing here? We're gonna do a maze. This maze is available. It's not available here yet, but it is available. Where is it available? If you're looking for more abacus, it's available here. My name is Lynette. Welcome. Hello. Thank you. Oh, hey. My child. Yes, right. It's a childhood toy, but it's actually very educational. Oh, thank you so much for the tiny kryptonite. Krypton. Yeah. So we have the abacus mazes. When we have the abacus mazes, right, what we can do is we're going to start understanding how to read the abacus in 2 digits. What does that mean? Okay, so here's a maze that I made. I made a maze, and I think it's cool. I think it's fun. So this is what a maze is, and what we're going to do is we're going to go through all these boxes just to see what the numbers are. And the boxes will tell, and the numbers will tell you what box and what path to go. So the first one I'm going to do is this one right here. What number do you think this is? That amazes me. How much is the puzzle book? I think I have it on for sale for $7 right now. I was going to up it. Oh, thank you, Char. 52. Oh, yeah, you're right. It is 52. Because when I look at it, right, and I compare it, this is 5 and this is 2. You're right. That is 52. Hey, Purple, welcome back. Oh, that's not the right one. So we have this next one is, what number is that one? That amazes me. Welcome, Purple. Okay, this one and that one. What number is that? Ooh, 57. Is that right? 57? I don't think that's right. Whoop, 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 whoop. Haha. Oh, hey, Melinda, welcome back. No, it's not 49. We have 1 over here, and we have 5, 6, 7. Hello, it's 17. It is 17. So, we're going to go over here. We're going to go 17. And what number is that? Okay, good. What number do we think this is? If I did this, I was close. You were close. You were close. You were adding a little bit too many beats, though. And then 5, 6, 7, 8. 28. Yes, thank you. Thank you. Ooh, thank you, Main Brick. Yes, 28. That's very exciting. Very exciting. Wow, what number is that one? We have this one. We're doing 2 digits, so it should be a little bit easier. 2 digits. So what number is this? Whoa! Whoa! Cha! We forgot the 5 at the top. It is 95. We got 5, 6, 7, 8, 9, and 5. 95. Thank you, Cha! Okay, what are we doing? Oh, we gotta go up here. So, we have that number. Okay, we have this and we have that. What number do you think that is? This is, what is this tool called? I've never did math this way ever. Jessica, it's called an abacus. Ooh, thank you, 15. Yes, thank you, 15. 15. We got to go down. We got to go over here. Yep. It's called an abacus, and it is a math tool. This math tool will help. Oh, sorry. This math tool is going to help us learn how to add, subtract, multiply, and divide. Ooh, yeah. There you go, Dragon. Where can I buy it? Oh, yeah. You know what? If you want, I have here at the TikTok store, or that's the small one if you like the colorful one, or I have the 13 one. So it is up to you. Oh, how much? No way, I gotta choose. How old is your son? How old is your son, if that's okay, if I can ask you? I'd like to know, because it all depends, like, where to start. 10. He's 10. You know what? If he's 10, he would enjoy the maze. He would enjoy the mazes. And with the maze, I added a mask maze. And this mask maze is to help what? Cover the path so you don't cheat. So I added a mask maze, but if you want to, you can download this mask maze, so then you can actually print it on cardstock. The reason why I did that was because the paper that is in the book is a little thin, and so you can still see the answer. So he is a development delayed. Oh yeah, that's not a problem. You could try this one first. We could go work. I'll show you. I'll keep going further, and you can see how it goes. So if you want to stick with me, Jessica, let me know. Oh, we did this one. This one's not 10. This is, oh, right, 19, right. So we're done with 19. We got to go 19 in here. Let me continue on with all of my activities and see if you think it will work for him. Yeah? Let me know. But I'll tell you how to, what we're going to do is we're going to learn how to add and subtract. He's also another workbook. Yes, yes. Let me finish this and I'll show you my other workbooks. Yes. We have 20. We have 9. Whoop, whoop. Oh, kryptonite. No. 32? Where do you get 32 from? 30? No. 1, 2. This is 20. This is 9. 5, 6, 7, 8, 9. Thank you. I tried to... No cheaters! No freeloading numbers! Cheater! No. So we have this number. We have 1. And then, that's in the tens column. And then we have this. I'm cooked. Don't be cooked. This is fine. We're okay. It's hot today. I just got back too. And I was like, what? I gotta get out. Okay. So what number is this? We have this number. And then we have that number. Woo! I saw a TikTok where the kids stand in the class saw the... Yes! You're absolutely right. Huggy Thuggy. Yes. 77. Yes. Thank you. Thank you. Thank you. Yes. Thank you. 77. Yes. Main brick. Yes. Fantastic. Fantastic. So what we're doing is we're just learning how to read the abacus. This is the secret to all the kids doing this. Are you going to be able to do it? If you practiced, you could. But I don't. Thank you, Dragon. Yes. You could practice and be like this, but it is up to you where you want to, Thank you, Splendor. Yes. 23. Good, 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 good. Okay, we're almost done. We're almost done. So we have our final, we have this one, which is, what number is that? I'm going to have to do more research. Oh, okay, cool. Oh, have a good night. Ooh, it is late. It is late. I apologize for being so late. I just got back from science camp. Yes, 31. 31. Thank you, thank you, thank you, thank you. And then our final answer is this one and then that one. So, do you know when these were made? I feel like they were in the I feel like I've seen them in Rome time. Yes, you're right. In Mesopotamia, when they started to do the figure. Thank you. Yes, 91. So Mesopotamia, like before Christ. I don't know. Like how hard is it to learn math on this? It's actually quite easy. There's a lot of people that believe it's very easy. Hello, Audrey. Welcome. Welcome, Audrey. Thank you so much for liking the live. Yes. Oh, and then this is the next one. The next one would be the and then in the same, I have a puzzle, and I called it a reverse maze. And so the idea here was I give you what the number is. So I give you what the number is, and what we're trying to do is we're trying to figure out how to color this in. So that was the one thing. Oh, so the question so before Christ, when they started doing like bartering system, and this is on the 10 base, because it's 10 base, it's just exactly like the decimal system. However, hello, Splendor. Okay, you'll come back. Okay, I'll see you later. Thank you. So Emma, oh wait, somebody asked about when was it made. Oh, main brick. So they were made before Christ. I believe it was like right around the time when they started to do bartering system, if that makes sense. And they needed to keep track, and they needed to keep count, and they couldn't keep the count in their head. So they started using these pebbles, which is the another word for abacus. Abacus means moving pebbles. And so what they did was they used it just to count, and it's just to add. So there's another one where there's a 10 bead, and the 10 bead is just one by one. But because we started counting, there was a Chinese one. Chinese made a 2 and 5. So there's 1, 2, 3, 4, 5. It works exactly the same. So we have 1, 2, 3, 4, 5. We trade this in, and we do this one is always going to be the 5 bead. So that's 5, and then 6, 7, 8, 9, 10. We got to do another trade, and then that would be 10. So then because this is 10, we do another trade. That would be it. So I think it started when they started to do more than just bartering, because they wanted to make sure that everything was created. Hello, E. Welcome back. Welcome back. Did that make sense, main brick? So, and then what happened was after the Chinese figured it out, made it into more of a tool, then the Japanese made it more efficient. So, I hope that made sense. I know I go kind of all over the place. And Emma, how difficult is it to learn? It's not difficult to learn. Let's do a little review for Emma. I don't know. Oh, that was perfect. Thank you. I'm very excited when I talk about it. I just got to get into the live. Okay. So, Emma, let's do a little review. We have 1, 2, 3, 4, and then the top beat is 5, 6, 7, 8, 9. Hello. Thank you for the review. I got here in the end of the explanation. Oh, yay. No. You know what? You need to let me know if you don't understand how to read it, because I don't know you came in. So this is 9. So we have 9, 9, 9, 9, 9. These are all 9s. If I did this would be all 9s. So then if I did this would be all 5s. Whoa. Her excitement is contagious. Melinda, that's funny. I just dropped in. I haven't seen this since the 1990s. Whoa. Yeah, that's when I was the 19th century. The 19th century. Okay, so that's 5. So we're going to count it again. We have 1, 2, 3, 4, and then 5. After 5, we have 6, 7, 8, 9, and then we have 10. When we see this, we have our place values. We have our place values. We have our 1s, our 10s, our 100s, our 1000s, our 10,000. Does that make sense? I've never learned this, Schoolie. Thank you so much, Apple user. I'm not sure if you're the same Apple user, but there's a lot of Apple users. All right. So what are we doing? This is 10. When we do 10, we have 11, 12, 13, 14. Boop, boop. And then 15. I've got a lot of like other like crazy things. Okay. So we're all set here? We're okay with this? So then this one is what I called a reverse maze. The reason why was I give you the number and you're supposed to color it in. This is going to be one way because you can't really tell me what to color in. So I'm just going to show you what I was trying to do. So here's my maze, and in this I go 50, that's a 5, and then 4. 1, 2, 3, 4. And then it takes me to this puzzle, to this block here. I need to look at this number, which is 96. So 90 is 1, 5, 6, 7, 8, 9. And then 6 is 5, 6. Does that make sense? I'm hoping that's okay. And then it takes me to this one over here. And then, thank you for the heart me, Audrey. And then I have 29. So I need to make 29. To make 29 is 1, 2, right? That's the 20. And then 6. And 5 and then 6. Yeah? It does make sense. Whoa! I've never learned to read it. Oh, fantastic. Yeah, so this is the beginning part of my maze. Oh no, this is the second part of the maze. So the first part of the maze is I give you the number and you're supposed to find the answer, and then this one is I give you the number and then you're supposed to make the number. That's what I was trying to do here. So this is just called, what I called it, a reverse maze, and that was the thing that I was trying to do. Right? Okay. So that's a little bit about that. Okay, let's go into what adding and subtracting is. So, because I got some sounds. Okay. Let's do this. Let's do this. Contagious. All right. Now, what are we going to do? We're going to learn how to move the beads. That's what we're going to do. We're going to learn how to move the beads. Can you give a general explanation of what you're doing? Thank you, Daniel. I am teaching everybody how to use the abacus. This is an abacus, and this abacus helps us count. This helps us count. It helps us to do math. It helps us do arithmetic, adding, subtracting, multiplication, and division. I'm not sure if anybody knows how to do division. I know somebody was here. They learned how to do this in the beginning when they were young, but I was asking if they know how to do division, but they didn't respond. Anyways, so let's do a little review. We're going to review. We have our horizontal bar. This is our horizontal bar. This horizontal bar helps us track our numbers. So when we track our numbers, what are we doing? I want to count to 1. This is going to be so easy. This is 0. None of the beads are touching the horizontal bar. We have 0. Then we have 1. This is 1. Then we have 2. Right? That's not 2. That's 2. If we correlate it with pennies, that's 2. And then we have 3. 3 looks like that. I forgot. Can you teach me the 10 trick? Yeah, we'll go into it. We'll get into it. But I'm going to start with counting. Then we go into adding and subtracting 5, and then we'll go into the 10. Yeah? So this is 4. That's 4. So if I look, 1, 2, 3, 4. The reason why I use this as the money, because look at the money, there's no specific, like, not 1 is 1, right? This is the same thing. None of these is specifically 1. They're just the value of 1. So then we have 5. The value of 5 is this. That's the top bead. The top bead will always be 5. And then we have 6. So I do 6, 7, 7, 8, 8, 9, and then 9. Right? 5, 6, 7, 8, 9. And then we have 10. How do I know that this is 10? We have 10. If I match it up, 0, 1, hundreds, right? Ones, tens, 100, thousands, 10,000. How does that look? Is that all right? Everybody okay? We are going to continue on. Now, the one thing that we need to do is when we are working with the abacus, please be happy when you use the abacus. Be happy and you know it. Use the abacus. We're not going to be aggressive when we use the abacus. Why? Because it's a gentle thing. So when you look, the beads, the way the beads are, there's a edge to it. So you just need to use the top of your finger, right? So when you look, JP, do you have a specific question for me? Like an actual arithmetic question, so I can explain it to you, or is it just a general thing? Because if you're waiting for general, I can talk about it, something specific if you have a specific question. So when we look, notice that I'm only using the edges of the beads. right? And we're being gentle. The reason why is because the beads move very quickly, and if you flick too hard,
Flick too hard, damn it!
then your answers will become wrong. So the idea is, how do you calculate so fast using an abacus? That's what we're learning right now. We're learning how to use the abacus, and then as you learn how to use the abacus, then you'll know how to then you'll be able to calculate. You like that? I've got more. I can show you more. So, yeah. You like that? So when you flick, don't flick too hard.
Flick too hard, damn it!
The reason why is because the beads are the beads are very easy to move. So you want to use your left hand to hold the abacus and stabilize it, and then you'll be able to calculate it with your right hand. So when you're looking with the abacus, make sure that you're just being gentle with it, and it'll be easy just to move the beads, right? All right. So that's about how to move the beads. Okay. It gets better. But wait, it gets better. Oh, so we're okay with this? We counted 0, 1, 2, 3, 4, and then 5. That's the value of 5. That's not my... Okay, there. Value of 5. We have 5, 6, 7, 8, 9. Right? We have 9. It seems the decimal is opposite from U.S. arithmetic? No, no, no. It's the same. It's exactly the same. It's just how you write it. No, no, Daniel. It's exactly the same. So if I write 10, I'm going to have it on the abacus. 1, 0. I'm not sure how it's opposite. The decimal is opposite from, no. So then this decimal sits here. So if I did 0, 3, right? 10.03, it's exactly the same. Does that make sense, Daniel? It's not the opposite. It follows exactly like the US. So, okay, so we got that. Left of the decimal is less than 0. Anything after the ones is less than, right? Anything after the ones is in the decimals. So if I have 1, right? 1, and then this is 10. 0.1, 0.1, or we do 0.01, 0.02, right? It would be 0.03, 0.03. It works exactly the same as the U.S. arithmetic, U.S. decimal. Not less, but portion of the whole number. Yes, exactly. Yes, exactly, because it doesn't matter. There's no negative. We don't have negative on the abacus. We only have positive numbers, or we have decimals. That's the only thing. The image is not flipped. I'm sorry. The image is not flipped left. Our full digits are right, and our decimals. Yes, exactly. Oh yes, thank you, balls. Yes, exactly. If it was flipped, then then this wouldn't read well. You're absolutely right, balls. Welcome back. Welcome back. I missed you. I missed you guys. Does that make sense, Daniel? Thank you so much, balls. All right. So we got 10 and we got 11. All right. There's typos, but I'm glad you understood. This is the way.
This is the way.
This is the way. This is the way.
All right. Thank you, guys. All right. We're going to continue on. So that was a little bit about how to move the beads. We're going to continue on learning how to move the beads. The reason why is because this is going to be the precursor of how to add and subtract. So obviously the first thing we did is we understood how to read the abacus. We learned how to correlate the numbers with the abacus. And so I just have like little activities. This one was for preschool kids, but I wanted to get the kids young. But what we're going to do is we're going to start going into towards the end, which is adding. What we're going to do is we're going to add the thumb up. What does that mean? We're going to look at our number. We're going to look at the second add-in. We got to look at the add-in. We don't focus in abacus world. We do not focus on the result. We focus on the add-in. When we look right? We want to do 5. Here's my question, 5. When I clear it and I'm going to add the 5, I'm going to add my 1. What I want to do is I want to focus on the number 1. The reason why is because I want to know what the add-in is. And then the question is do I have enough? Can I do it? Yes, we can add the 1. So my final answer is 6. So I have, and then my next question is 6. If I have 6 and I add the 1, can I add the 1?
Welcome
Whoa, no, wrong one.
to the room.
Right? So we add another 1 and we can add it, and then my final answer is 7. So we've done the 2, we've done the 1, we're going to go into 2. We're going to start going through each and every one of them. Notice I'm not focusing on the result. I'm focusing on the add-in. We want to make sure we have enough beads to add. So if I have 6, can I add 2? So I'm going to add these 2 beads. It doesn't matter which 2 beads as long as I add only 2 beads. So my final answer is 8. I have 5, 6, 7, 8. Does that make sense? So if I have 2 and I want to add another 2, is there enough to add another 2? Right? So now we're going to the next one. We go to 3. Same thing. It's just the 3 beads. If I have 5, I'm going to add the 5. If I need to add the 3, I'm going to add these 3 beads. So my final answer is 8. Does that make sense? Anybody have any questions? I'm just going through the book to make sure that we all understand how to add. So the 4 is not, there's not too many questions with 4. So we have a 0 and then we add the 4. The reason why, because there's always going to be 4 beads, no matter what. Thank you, Audrey, for TGIF. All right. There's not too many questions for the 4. Because if we have the 5, when we add the 4, add 4, can we add the 4? Oh. Yes, we can. So we're going to add the 4, and our answer is 9. Now, when we look, here it is. When we look, if we know how to add, we will know how to subtract. Why? Because if you notice, when we add, we go to the horizontal bar. When we subtract, we move it away from the horizontal bar. We move it away from the horizontal bar. That is subtracting. So it's easy to see when we add, we can subtract. When we add, I want to subtract 1. I take away the 1, which means I'm just going to remove it away from the horizontal bar. So my final answer is 2. This one is minus 1. Minus 1 is just moving the 1 bead down. Does that make sense? So we're going to continue on with the 2. Same thing. If I have 4, I'm adding 4 to the horizontal bar. I need to subtract 2. When I away from the horizontal bar. So what I'm doing is I'm moving it away from the horizontal bar. Now I'm subtracting. My final answer is 2. And then I have 3. 3 is easy. Why? It's the same thing, but just 3 beads, right? We're starting to get to see the pattern. Do we all understand the pattern? So I have 4 and I'm going to take away 3. When I take away 3, it's just these 3 beads. That's all I'm doing. I'm just moving it away. That's it. That's it. Easy peasy. Easy peasy. Lemon squeezy. So in 4 is the easiest. Why? Because there's only 4 up and then 4 down. That's it. Anybody have any questions? So then we have 5, we have 9, and I want to take away 4. That's it. My final answer is 5. And then again, we're going to do the same thing with the 5. When we add the 5, right, again, we're looking at our add-in. When we look at our add-in is what we're focusing on. So it's 0 and plus 5 is 5, right? Going down to the 5 is moving it away from the horizontal bar. And again, it's the same thing with the 6. What? 6 is what? We add the 6 is bring together at the same time. When we subtract the 6, we want to move it apart. We want to take it away like this. So if we have 1 and I want to add 6, I'm going to add 6 like this. If I want to take away the 6, I move it apart like this. Does that make sense? So all I'm doing is adding and subtracting. Adding 6, subtract 6. Add 6, minus 6. Add 6, take away 6. There's so many ways to add the 6. All right. Take away the 6. So it's the same thing with the 7, right? 7's the same thing. If I have 2, I'm going to add 7. I'm going to have 5, 6, 7. 6, 7, right? I'm going to add these 2 beads, and then I'm going to subtract them, right? If I have 9, subtract 7, I do this. If I have 1 and I add 7, I'm going to do these 2 beads, these 3 beads. If I subtract 8 from 7, I move it away like that. Can you do multiplication? Yes, we can do multiplication after we figure out how to add and subtract. But yes, you can do multiplication and you can do division. Yes. I need one of these for my Monopoly with friends. Ha ha. You could use it with your Monopoly. Okay, so we're going to continue on. We have 6, we have 7, we did 8. 8 super easy. Same thing. Add the 1. Is there enough? Yes, there is. I'm going to add 8. If I subtract 8, it looks like that. Make sense? Easy, right? I don't know if Emma is still here. Does that make sense? So the same thing with the 9, with the 9. When we add the 9, take away the 9. Okay. Question. Well, what happens when there's not enough beads? Well, if there's not enough beads to add the 9, what are you going to do? What are we going to do? We got to utilize this thing called the 5. What? What are we going to do? In school, we teach the kids. We're teaching the kids how to add 5, how to make a 5. Hey, Huggy Thuggy, thank you so much. Thank you so much for the likes. Thank you so much for the likes. All right. Here's a little story of a number named 5. Oh, that's a good one. I should do that one. Okay. 4 plus 1 is equal to 5. 1 plus 4 is equal to 5. These are pairs that we are going to know, right? These are pairs that we understand. Whoa, that's not good. Okay, why are we teaching this? Why are we teaching the children 4 plus 1 is equal to 5? It's because they're friendly numbers. That's fantastic. Those are friendly. However, in Abacus world, we make it better. We actually take it one step further. Oh, that's right. That's what I was going to do. So what we're going to do is we're going to look at this Abacus formula. This is also in my shop. Let's see if I can find it. Ah, there we go. So this is in here. What I have is how to utilize, and what we're going to do is, if you notice, we're going to figure out what we're going to do is we're going to do this. We're going to make sure we don't have any freeloading numbers, right? This 5, we're going to make this 5. Making a 5, this is what we're going to do. What? Why are we going to do that? Well, what we're going to do is we're going to understand that we have this formula, right? What grade level is this? Right now, I think we're in... I think we're in kindergarten or maybe first grade, but this is the basics. So really there's no grade levels, T, just so you know. I'm trying to make it more grade level specific, but everybody needs to learn how to read the abacus. And everybody needs to learn how to use the formulas. But once you know how to use the formulas, then the sky's the limit. It's very scalable. I'm sorry, Abacus method is very specific, and right now, as we speak, we don't have anything specific that's grade specific. What we have is beginning abacus or intermediate abacus, if that makes sense. I'm trying to make it more grade specific, but it does take time to curate those questions. Yeah. Oh, so T, let's do a little review. To do a review for, okay, Tufu. Yeah. Okay, let's do a review. We're going to count on the abacus. 1, 2, 3, 4. And then 5. The top beat will always be 5. We have 6, 7, 8, 9. After 9, we have 10. Does that make sense? If we're okay with that, I'm going to continue on understanding why we're using this. So in school, we're teaching the kids 4 plus 1 is equal to 5. Anybody, are we ready? Okay, good. Thank you, Tufu. Okay. So what's the question? The question is if I have 3, right? Here's my question. 3 plus 4. That's so easy. It's easy, but I'm showing you the fundamentals, right? What I want to do is I want to show you the fundamentals. Why are we doing this? Well, I don't have any more beads to add the 4. If I don't have any more beads to add the 4, what am I going to do?
You need modifications! Modify!
What does that mean? Well, what I'm going to do is I'm going to isolate this variable. This is the variable I'm going to isolate. Why? Because I'm going to use this one, right? Because this and this is the same. So what does that mean is I'm going to, since I isolate it, right? That's a very algebraic term. I'm going to make it equal to 5. This is too much. 5 is too much. So what I'm going to do is I'm going to minus the 1. Now we're balanced. Because we're balanced, this is now directions to the abacus. Now we have directions. What does that mean? All I need to do is add the 5, and then take away the 1. And my final answer is, what's my final answer? What did I just do? What's my final answer? My final answer is 7. Does that make sense? What are we doing here? Are we all right? Seems a little quiet. Does that make sense? How are we doing it? Are we all right? Abacadabra. Abacus! How quickly can you do this math? I can't follow the gymnastics. I can't follow the gymnastics your brain just did. Okay, so thank you, Dory, for letting me. Okay, so let's start over again. We're gonna count 1, and you're absolutely right. It is brain gymnastics. 1, 2, 3, 4. Right? 4, and then 5. After 5, 6, 7, 8, 9. Thank you, balls. 9. This is 9, right? 9, and then we have 10. But I'm going to write it down so I don't lose it. Oh, wrong one. Does that make sense? Okay, what is it? 20 times that by 25. So, Daniel, we'll keep that there. Okay. I'll keep Daniel. Daniel, I have your question. We'll keep it on the we'll pin it. Now, from the point you need to understand the equation effects to move the beads. Yes, you get the 3-digit multiplication and then it's more effective. Yes. Okay. Okay, so what are we going to do? Here's my abacus. I'm going to have 3. I have 3. Now the question is if I have 3 pennies, 1, 2, 3. I want to add 4, right? I want to add 4. But I only have a penny. I'm sorry, I only have a nickel. I'm not sure where everybody is, but a nickel is worth 5 cents. So what we're doing is we're using this 5 cents, okay? This 5 cents is all I have. I'm going to give it to you, but is only worth 4 pennies. So what's going to happen is I'm going to give you the 5 cents. But I've given you too much. You need to exchange that back, and I need to take away 1 penny. So I'm going to take away 1 bead. So what did I just do? I just did a trade. My answer is 7. It's okay, the same way as in the beginning. Yeah, yeah. Everybody always wants to know how to multiply and divide. Dory, did that make sense? So what we just did, I was confused how we got the 5 when we got the 4. Get it now. Okay, good. Yeah. Sometimes depending on where we are with this, it all gets confusing. So we can do it again. If I have 4, right, I'm going to show you how versatile this is. If we have 4 in the abacus, I have 4 on the abacus. I only have 1 nickel. 5 cents. All I have is 5 cents. I'm going to add 4. I want to add another 4. I'm going to give you my nickel. I'm going to give you my 5 cents. But that's too much. I'm going to take away 1. So I'm going to take away 1. My final answer is I'm visual. That's why I want to learn this. Oh, good. Yeah, not a problem. Yes, thank you. Thank you, balls. Yes, 8. My final answer is 8. Yes, thank you. Plus the 5 minus the 1. You will notice now what I've been giving you is directions on how to move the abacus. So the first thing we're going to do is we're going to understand, thank you, balls. So the first thing we're going to do is we're going to understand how to move the beads. We know how to move the beads. Now what we're doing is we're learning number patterns. This is very versatile, right? So instead of learning doubles, 4 plus 4 is equal to 8. What we learned is 4 is equal to plus the 5 minus the 1. So now she sells the abacus for only $10. Oh, yeah. So now what we're doing is we are learning how to calculate while using the abacus, if that makes sense. So what happens is if I do 2, when I do 2, and the question is can I do it? No, I can't. So what do? I need to plus the 4, To plus the 4, I need to plus the 5 minus the 1. And my final answer is 6. Does that make sense? So what am I doing? I'm using the abacus to help me calculate. I'm using the abacus to visualize the numbers that we have. Oh, good, Dory, good. So we can continue on, right? So let's do 3. What? 3? 3 is the same. Notice that there's a pattern. We are compounding our information. We're compounding our what are we doing? We're compounding our knowledge. We know how to make a 5. To make the 5, all road leads to 5. Not necessarily. Not necessarily. We're going to continue on. But this is the first thing we're going to do is we're going to
You need modifications. Modify.
3 is equal to 5 minus 2. So what we did is we modified it. We want to isolate the 3 and we want to make it into 5 minus 2. So my question here is 4. When I add the 4, I want to plus the 3. When I plus the 3, I'm going to plus the 5 and then take away the 2. So my final answer is 7. Does that make sense? So what we're doing, again, notice what we're doing is we are focusing on the add-in. We're not focusing on the result. We're focusing on the add-in. And that's a very different way of thinking. It's a mindset shift in elementary school. I'm not sure why we start teaching the final result as opposed to how do we get there. So what I'm trying to show you the journey. Right? Abacus is a journey. Abacus is life. Abacus is, the process to get there, right? Marry the process, divorce the result. We can look at the result at a later time, right? We want to know what the journey is. Just like a movie, we want to know what the movie's about, but we don't need to know what the conclusion is. Everybody wants to be happy, but how do you become happy? So what we're going to do is we're going to do it again. I can show you if I have 3 and I want to add another 3. Again, we are not, I feel like American math is less about figuring out the equation, more about memorizing. Yes, I believe so. I'm mainstream and I'm a big believer of it. I'm a huge supporter and I'm very much in favor memorizing the answer. Yes. I'm mainstream. I'm a big believer of it. Big believer of memorizing? Takazia? I'm a huge supporter and I'm very much in favor. I'm sorry, I'm not sure what that means. Takazia. Okay, so what we're doing is we're going to add the 3. When we add the 3, again, what we're doing is what? We are going to plus the 5 and take away the 2. So what my answer is 6. We don't memorize 3 plus 3. We memorize the formula. We memorize the partners, right? We know what the partners are, and that's what we're doing. Is we're taking this information, we're taking this concept, and we're understanding it, and we're making it, we're changing, we're using it to our advantage, right? Does that make sense? So when we use it to our advantage, what we're doing is we're taking this knowledge and we're understanding it. So we can do it again. There's the other 2, right? We could do it again for the 2, and it's the same thing as minus the 3. So we could do the same thing. We have 2, same concept. Yes, thank you. Fact families. Yes, exactly. It is fact families. We are using the concept of fact families. Thank you, Dory. Yes. So when we look at it, right? But you know what? It's the same concept of fact family, but we're leveling it up, right? We're Super Marioing it. So again, what we're going to do is we're going to take this 2. Why? Because if I have 4, and I look at my abacus, I have 4, and I want to add the 2, I don't have enough beats to add the 2. So we have this fact family, but we're going to modify it a little bit. We're going to do 2 is equal to 5 minus 3. Plus the 5, take away the 3, and my final answer is 6. We have eaten the mushroom. Yeah, yes, yes, yes.
Welcome to the real world.
That's beautiful. We have eaten the mushroom. I will try to figure out if I can put that into my little sound bites. But I love it. Where did you get the 6? Oh, so you are very passionate teaching, and I'm very much appreciative. Oh, thank you so much, Daniel. Thank you so much. 93 W. So what we're gonna do is we're gonna count 1, 2, 3, 4. These are 4 beads, right? This is the value of 4. I'm sorry, each bead is a value of 1. When I do 4, and then the top bead is 5. 5, and then 6, 7, 8, 9. Does that make sense, W? So we have 9, so that's how we get 6. 5, 6. And then we have, yes, Jojo, all the blue beads is a value of 5. This is 10. This is 55. Does that make sense? This is 56, 57, 58, 59. Yes. All the top beads, all the blue beads is a value of 5. Yes. Thank you, Daniel. I appreciate that. Okay. So, we're okay with adding the 5. We're okay. We added the 5. We know how to add the 5. Guess what? If we know how to add, we will know how to subtract. Now, if you notice in mainstream math, when we subtract, we have all these other strategies. But in Abacus world, hey, Kaylor! In Abacus world, if you know how to add, we will know how to subtract. What does that mean? Well, it's the same way, but backwards. I'm back. I am back. I just got back actually today. I got back from science camp. It was fantastic. It was just a lot. I've been out for about 5 days. Thank you so much. Sorry, I've been overwhelmed lately. I'm not sure if I did come back today. Yes, long time no see. Yes. It was fun. It was fun. The kids, I had such a beautiful cabin. The kids were so good. The kids were so good. Thank you so much. No, yeah. Yeah. Okay. So what we're going to do is we're going to do 4. Why are we going to do minus 4? Because the question is 8 minus 4. When we minus the 4, again, what we're going to do is we're going to isolate the variable. We're going to...
You need modifications! Modify!
This looks very familiar. Minus the 4 is equal to minus the 5 plus the 1. So if you look, we're now doing the opposite. What does that mean? Well, if I have 8 and I want to take away the 4, I'm going to minus the 5, which is what we did. Minus the 5, and then we're going to plus the 1. We add the 1. So what did I just do? I just showed you this formula, told you directions, like a mapicus. Does that make sense? So we can do it again. If I have 7 minus 4, what are we going to do? I have 7. I want to minus the 4. If I can minus the 4, what do? Minus the 4 is what? Minus the 5 plus the 1. So my final answer is 3. How are we doing? We're all right? This is Abacadabra Abacus. How are we doing? Does that make sense? So the answer is in the middle. Oh, that's a very good question. So what I did is I'm using this ones indicator. This ones indicator tells me where my ones will be. So I choose this location to be my ones. I could choose this one. Oh, good, Jennifer. That's fine. It takes time because I've been teaching for more than 20 years. Hola, wake, oh, okay. Okay, I don't know if I can. I'm sorry, I don't speak Spanish. I would have to Google Translate this. This is, all I know is this is an abacus. Esta ensign, I don't know. I'm sorry. How? What? Math? What math? Oh, what grade? Thank you. What grade? Oh, so this is, in the beginning we start from preschool? Kindergarten. kindergarten, first grade, but I'm trying to make it into higher grades. But right now, it only is the beginning of kindergarten or first grade, maybe second grade. Yeah. Thank you so much, W. Thank you so much. I appreciate that. Does that make sense? So what we did is we're understanding we did the plus and now we're doing the minus. Notice when I add the 4, I'm moving the top bead and the bottom bead. When I subtract the 4, I'm only moving the top bead and the bottom bead. Does that make sense? So now what we're looking at is we're looking at number patterns. There you can see the patterns. Brawls. Thank you so much. Do you teach at school or only online? Right now I'm only online. Where am I in the world? I am in Los Angeles, California, United States of America. I have to say that because sometimes I forget that we're actually international. There's a few people that was from Ghana and Uganda and other places in the world, and I forget. So that's where I'm at. I'm in California, United States. Los Angeles. If you're in the area, I do have a learning center that's down the street. If anybody's interested, if you want it in person, I am offering online. I do have an online class that I do provide. Yeah, but I'm doing this, and I also have workbooks. So I have a bunch of workbooks. If you're looking into understanding how to make it, so I have these workbooks, and then I also have this laminated abacus formula. So this is to help write it out. This was for, and then I have it where I can show you where the formulas are, and then and then what we're gonna do is we're gonna do how to make a 10. So I'm not sure if we're ready to make a 10, if that makes sense. So what we just did is we learned how to add the 5, and we learned how to subtract the 5, and that's what we were doing. So after we learn how to do all of that, we can go into adding a 5. How are you doing, Jennifer? How about you, Dory? What's going on? Daniel, how are we doing? Are we ready to make a 5? I know balls is good. Got it. Okay, good. Good. We're ready? Okay, so what's the next one? The next one is we know how to make a 5. After we know how to make a 5, guess what we need to do? We need to learn how to make a 10. Learning how to make a 10, definitely. Yeah, you're always. Let's make 5. Let's make a 5. Okay, so let's continue on making a 5. So here we have this number. Oh, do I have it? No, I don't have it yet. Oh, I'm supposed to. No, I don't. Okay, here. What am I doing? Okay, we'll do this. So here is we're gonna subtract. Here we're gonna subtract. I'm still here. I'm not a big fan of it, but still here. This is so advanced. This is not really advanced. I'm moving everybody forward really fast, but usually my classes are it takes time. But I'm talking to adults. So, okay. I think I'm talking to adults. Oh, not a big fan of California, but I'm still here. Okay, Daniel. I don't know why. Why being in California is a problem? But this is not a Californian thing. Oh, thank you, AZT. Adult here. Yeah. Okay, good. But I do know, you know what? I do know that there's a bunch of kids that are learning from me, and they actually watch me during school, and they show my stuff to the teacher, and the teacher allows it. I'm like, whoa, that's funny. So, thank you so much. Okay. Do you think this is advanced? Just wait. Yeah. All right, we're going to continue on. -3. Again, what I did here is I was trying to show the 5 frame and to also understand, what we're trying to do. So when we color it in, right? We color it in 1, 2, 3, we notice we have 2 left. And again, this is where we do the modification. So here is minus the 3 is equal to minus the 5 plus the 2. It would be surprised how many of us adults are regularly come to class. Yeah! So here is the question is 7. If we have the answer, right, the question is 7. If I have 7 on the abacus, I want to minus the 3. I cannot take away the 3. What do I do? To minus the 3, I need to remember this formula. It's a formula. It's a formula, and it tells us how to do it, right? So all I got to do is minus the 5. So I take away the 5, and I plus the 2, and I add the 2. Thank you, Danielle. Danielle. So, thank you for the heart puff. This is 4. My final answer is 4. That is what I did. So here is a sample question. This is the formula that we need to memorize, right? So this is nice because we know that if we're trying to make a 5, if we want to minus the 3, we have to plus the 2. So here I have it where I wanted to show you, I want to minus the 5 plus the 2. So when I have 7, I'm going to minus the 5 plus the 2. Minus the 5 plus the 2. Up together at the same time. So here, this is the formula you write, right? Minus the 5 is equal to minus the 5 plus the 2. So this is one of my other workbooks. And I'm just kind of going through the workbook itself. So that's a little bit. So here is another activity. And we do it again. Here is a question. My 8, if I have 8 and I minus the 5. Hey, Dolce! If I minus the 5, I want to minus the 3. Can we do it? So we do not need to go to the 5. We just need to take away the 3. Don't go too far ahead. Only do what's needed. So that's the answer. The answer is 5. Here is the question. We do 7 again. If we do 7, can we do it? No, we can't. So then we go into understanding that we need to minus the 3. I'm not going to lie, I hate math. I'm so bad at it. Oh, but if you use the abacus, you'll be fine, Draco. You'll be fine. Minus the 3. I'm so happy you're here. Welcome. Minus the 5 plus the 2, right? So we're going to minus the 3 is equal to minus the 5 plus the 2. My answer is 4. Does that make sense? Why can't we do the... Well, oh, the reason why is we're going to take away the... we're going to do is 7 minus 3. That's the question. The question is a 7, right? Take away 3. If you can see, I don't have enough beads to minus the 3. So I have to utilize this 5. That's why I need to do it. That's why we are using this formula. Minus the 3 is equal to minus the 5 plus the 2. That's why. Does that make sense? So what we're going to do is we're going to go to the flower pot and we're going to take away the 5, but that's too much. So what we need to do is we need to add 2 flowers. So we add the 2 flowers. So my final answer is 4. Does that make sense? Oh, good. Oh, good. So this here is to write the formula. Minus 3 is equal to minus the 5 plus the 4. That's what we're doing. So again, we do 6. We can do it again. 6 minus the 3. Is there enough beads to minus the 3? No, there isn't. Right? That's always the question. Always the question is, can we do it? Oh, makes sense. Good. Good. Good.
Welcome to the real world.
So we have 6. Can we take away the 3? No, we cannot take away the 3. We will go, thank you, Dory. Yes, we're going to... Oh, yeah, sorry, minus the 2. Yes, thank you, thank you, thank you. Plus the 2. You're absolutely right. Thank you, thank you, thank you. So what we're going to do is, minus the 5 plus the 3. Plus the 2. And my final answer is 3. I see 3, though. Minus the 3 is equal to minus the 5 plus the 2. Yeah. We were going to take away 2. So we need to add this 2. Does that make sense? So if we need to take away the 2, take away 3, And then we're going to add these two. So what we're going to do is we're going to minus the 5 plus the 2. And my final answer is 3. We can do it again. This one's easy, right? Do we have 5? Take away 3. We don't have enough to take away the 3. What do we do? Minus the 3 is equal to minus the 5 plus the 2. Minus the 5 plus the 2. So my final answer is 2. Yeah? How are we doing? So this one was an exercise. How do we not have enough beats to take away the 3? Generally want to learn. For everybody in this chat, it only works when the numbers, if the numbers is less than. Oh! But if I have this, W, I want to take away the 3. This is counted. These are not counted. So when you're looking at this. Is there enough beats to take away the 3? This only works if the number on the bottom is 5 or less. Yeah. So that's the question. If I don't have enough beats to take away the 3, then what do? I need to minus the 5. That's too much. And I need to add the 2. So then we're left with 3. Does that make sense? So it's the same thing as this. If I have 5 nickel, if I have 6, right? But I don't, so the beads on the line, yes, exactly. The beads on this line, the horizontal bar is what's being counted. Yes, that's how it works. Yes. Yeah, that's how it works. Yes, absolutely. So if I have 6, but I only have, what is it? I don't know how to do it minus. The difference. Hey, Katie. What did, hold on. I'm trying to. I've lost it. Where did it go? I have all of these prompts. Okay, you know what? I'm going to do this. We'll do this. There we go. So every column. Whoa. Hey, Em! Welcome back! Place value. Yes. Apple user. Yes. No, don't do the money with subtraction. Yeah, that's what I was trying to figure out. Money with subtraction is tough. You're right. I think the abacus work is healing my math trauma. Oh, good. I'm so happy. Yeah, the money with the, yeah, I think the money would be kind of difficult. Yeah. I think abacus will help heal my math. Last class I realized, oh, sorry. Last class I realized, ooh, I'm just trying to find my comments again. Sorry. I'm just want to keep last class. I realized it was a bit more confusing. Yeah, that's what I was thinking too. All right. Hey, Katie. Okay. I missed my abacus time. Yeah, I'm still here. I can see how fast you can do multiplication. I'm still here to see how fast you can do multiplication. All right. Katie. Okay, wait. 300, 200. No, we can't do minus, right? So if we do 300, 1, 2, 3, 300 minus 200, 1, 2, 200, then I'm left with 100. Okay. Katie, multiplication is a long process until you need to memorize the motions. Okay. Katie, so we have our ones, right? Ones, tens, hundred, thousands, 10,000s. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. So we have 10, 20, 30, 40, right? Hi, Katie. You guys are so funny. Does that make sense? So now we're at 40, and then we have 50, 60, 70, 80, 90, and then we have 100. Does that make sense? We have 100, 200, 300, 400, and then we have 500, 600, 700, 800, 900, and then 1,000. All right. How are we doing? Okay. Okay. Daniel is very anxious about multiplication. Let's jump to multiplication because Daniel is very anxious. Let's see how fast we do it. I'm going to use this one. Also, dinner's ready. And so I got to go to dinner. I appreciate everybody's here. So those are, okay. We will have to leave off with understanding how to do the +5, and then we'll jump into multiplication. Enjoy dinner. Thank you. Oof, you messed up all good. We didn't, yeah, right? We didn't learn the 10. Yeah. See you after midnight. Yeah, I think I'll have enough energy for tonight. Let's do the division, and then we'll go into. Thank you, Dory. Thank you. I appreciate that. So, Daniel, very engaging. Oh, good. Daniel, we got to count our digits. We got to count the digits because we need to know why we're going to put it on the abacus. So we're going to count 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I'm going to put my answer here. Does that make sense? So when we look, we're not going to go to new math. We're not going to do 200 times 400. We're not going to do that. That's that big no-no. What we're going to do is we're going to do distributive property. We're going to do 2 times 4. Easy! 2 times 4 is 8. 8 is a single digit, and I go back one column, right? 2 times 2 is 4. 4 is a single digit. I go back one column, I add the 4. Okay, final one. 2 times 6 is 12, right? What we're doing again is we're not doing 20 times 20. That's too big of a number. It makes it too complicated. So what we're doing is we're going to do the very basics. We're going to do manageable chunks. When we do manageable chunks, I only want to know what this is, right? We know our multiplication fact. Our multiplication is 12. Is there enough to add the 12? No. Why? Because we need 1, we need 2. We need 1, we need 2. We know how to add the 1. When we add the 1, what are we going to do? Plus the 1 is equal to what? Plus the 5 minus 4. So plus the 5 minus the 4 and add the 2. Do we got it? We're all right? So I'm done with the 2. I am done with the 2. What am I going to do next? I am going to do my next set of numbers. I got to do 4. Count it again. 1, 2, 3, 4. 1, 2, 3, 4. I'm right here. We all right? We all right? So I'm just trying to position it because I need more space. Oh, there we go. I got it. Okay, there we go. So I'm over here. How do we get that? 1, 2, 3, 4. 1, 2, 3, 4. 5 times 4 is 20. Add the 2, add the 0, add the 2. Is there enough to add the 2? No, there isn't. This is where our 10s happen. Add the 2 is equal to plus the 10 minus the 8. Plus the 10 minus the 8, and then add the 0. 5 times 2 is 10. 5 times 2 is 10. Add the 1, add the 0. Add the 1, add the 0. 5 times 3 is 30. 5 times 6 is 30. Add the 3, add the 0. Add the 3, add the 0. Add the 3. There's not enough to add the 3. 3 is equal to plus the 5 minus the 2. Plus the 5 minus the 2. My final answer is, what is my final answer? 10,650. There you go. There's your answer, Daniel. I don't know if that was fast enough, but there was a lot of explaining. Obviously, it's different when I explain it, right? So there was a few things that we were doing. We needed to know our 5 frame, our how to make a 5, and we needed to know how to make a 10. And if we know how to do that, we can do everything. Yes, thank you. I don't know if that was fast. It was fast for me, kind of. You're awesome. Thank you. Thank you. Faster than the public school way. I believe so. I believe so. So what we're doing here is what we call distributive property. Why? Because we do one number at a time. We do one number at a time. We don't need to do big numbers. We make it down into manageable chunks. When they're manageable chunks, then it's easier to do. Okay. Is that all right? How are we doing? That was actually a really good number. That was a number because it wasn't too complicated with the adding of the fives and stuff. So that was an okay number. Obviously, the numbers can get more complicated depending on, the numbers that we have. But as you know, if you know how to add the 5 and you know how to add the 10, then you'll be able to scale everything. So, I'm hoping that makes sense. This is what the number is. Thank you everybody for joining. Thank you, Kat. Thank you for the... Oh, let him cook. Thank you, Katie. Thank you, Danielle. Thank you. Thank you, Balls on Budget. Thank you. I will come back. I always get so nervous to start the live because I'm always getting afraid of getting like spammers. Or people who are like, why are you making it more complicated than it is? And I'm like, you're absolutely very passionate about teaching. I very much respect you. Oh, thank you. Thank you. I appreciate it. You can do division, but I'm not there yet. You guys are not there yet. This one's harder to read without the colors. Oh, yeah. So if you want that, then there's this. So that would be like that. There you go. Does that make sense? If you're ever near, I got you. I'm here every class. I'm trying to get onto division for a month. Okay, Balls, you know what? We'll do division. Once I see you, you make a comment, we'll do division right away. I've got division. We can do division, we'll just confuse the class. That's fine too. We'll do it. So, Kat, does that make sense without the colors? Is that alright? Okay, bet. Okay, we'll do it. Yeah, I know Melinda. Melinda tries to drop in, but I know she also does she wants division as well. There's a lot of oldies here. And you guys are so patient waiting. It's amazing. But usually I think, yeah, usually when my off hours, I mean, there's a lot of people here. And I usually have to go back. So, all right. Gotta tune in when I'm waiting for division. Okay, I will have to put that down. Let's see. We will do that in the next live. All right, I will put that down, and I will see you in a bit. All right, thank you guys for joining me. I appreciate you guys, and have a good night. And I will see you in my next live. Toodaloo, kangaroo! Thank you so much, boss. What happened? Oh, there we go. There we go.